Today's class is important that you start from the beginning. Okay, sure. What do you mean by plan? See, I will give you the order of the topics, right? But I will not be able to tell you the exact class number because that will vary
So that
depending
will be fine.
on how quick you guys up intake the concepts,
Correct.
right?
So like, let me should I have some idea like which topics and
Yeah, I'll tell
how
you
many?
what will be the order, but I
Right.
will not be able to tell you how many class will be required to cover each. That will be difficult. Okay.
And probability like how like let's suppose one class, three topics, two topics accordingly.
No, I will not be able to do that, right? Because I mean, if I say three topics and you guys are not able to understand three topics, then the rest of the topics will flow over to the next class. That's what I'm saying. I'll not be able to give you that. Okay. I'll be
चलेगा
able to give you the order.
fine sir.
कहाँ गए थे सम्राट?
Okay, so people who are online, right? I see Priya Dubey, there is Realme 2, there is Vikas, there is Abhishek Patnaik. Why are you guys not on mute? Okay, if I talk about the order of the class, right? The order of the class will be, we will today start with basic statistics. Now, basic statistics roughly takes around 2 to 3 classes, which will include your concept of probability, probability distribution, estimation, and hypothesis testing. This will take around 2 to 3 classes. After this, we will go into linear regression. Linear regression will again take around 2 to 3 classes. After that, we will go into logistic regression, which will again take around 2 to 3 classes. After that, we'll go into decision trees, bagging, boosting. This should take around 1 to 2 classes. Then we'll go into support vector machines and naive Bayes. This will again take around 1 to 2 classes. Support vector machine, naive Bayes, and k nearest neighbor. After that, we will go into segmentation and principal component method, which will take 1 to 2 classes. After that, we'll go into time series, which will again take 1 to 2 classes. So these are the broad topics which we will be taking over, and this is the overall sequence. Yeah. Yeah.
Sir, I have one more question.
Yes. So after this time series, what we typically do is, so this will cover around 90 to 95% of the course. After this, we will take a break of around 2 to 3 weeks where you will be working on the capstone projects. After you are back from the capstone project break, what we will do is we'll have 1 or 2 doubt clearing classes. And apart from that, what we will also have is one class dedicated to NLP, natural language processing, 1 to 2 classes, one class dedicated on neural networks. Yeah, that's about it. Yeah. Capstone projects, you will be given 2 to 3 weeks to at least get a feel of them. There is no strict deadline, but you will only get the certification and whatever the placement assistance and everything post your completion of the capstone project. That project is individual. Yeah, there will be 7 to 8 8 data sets on which you will have to work. Yeah, they are all individual projects. Everyone will get the same data set, but you'll have to submit different codes. Yeah, just the same as what you got for the Python exercise, right? Everyone got the same set of questions, but had to make individual submissions, right? Here also same questions, individual, yeah, individual submission. We'll talk about them when we go there, right? But we'll have projects from different sectors, BFSI, healthcare, and all of that.
Sir,
We will not cover recommendation system in this as of now, but all the algorithms that we will learn here can be used for recommendation. Yeah. Yeah.
sir, we do have a, assignment for the basic Python, and when we will discuss the solution, in one problem I do have some difficulty.
Yeah. So what I will do is I'll send you the ideal solutions or the solutions as per me tomorrow. Now you can go over the solution. If you still have any question, we can discuss that in class. But we will not go over each and every question in class one by one.
Okay.
If you have any doubts specific to any problem, you can discuss here.
Thanks. Cool.
Sir, I have a question.
Yes.
So how much percent codes has been covered as of now?
How much?
Codes has been covered as of now.
Oh, I will not be able to talk about the percentage, right? But roughly we have covered 1/5 maybe.
Okay. Fine, sir.
Sir, I have a question.
You know, I don't have percentage of how much portion we have covered, right? I don't know that.
Yeah, that
Yeah.
is right.
Yeah. Okay. Quickly, what else? What else do you guys have to ask on this?
Sir, we had created dummies. So what method we will basically use to merge that dummies with our original data frame?
You can use either pd.concat, or you can use directly use merge, or what you can do is either pd.concat or merge. Yeah.
So pd.concat concat with axis1.
Yeah, axis1. Yeah.
Okay.
Okay. When we work on dummies, we'll come to it. Right? Yes. Anything else?
Sir,
So
I have a
what I
doubt.
feel,
Yeah. Go ahead.
so what
Sir,
I feel is like major portion covered by statistics only, right, in Python, right?
Sorry. Major what?
Major like major part is of statistics in Python, right? As it is going to be covered from 20 to 90%, like 70% comes under statistics. Am I right?
I don't understand the question. So everything is related to statistics, but we'll be using Python to implement them.
Yeah. Okay, fine.
Yeah.
Sir, I have a one question. So while creating the data frames, we are using the np.random.randint. In the brackets, we are using 0, 100, and 5. So 0 means low, 100 means high, and the 5 stands for here, sir?
So one second. So np dot what?
np.random.randint.
Oh, rand int.
Yes,
Oh,
sir.
0. Okay, just a second. Rand int. Let me go to the function. Okay. Again,
This one, sir.
if you have any question, what
Yes.
I would really encourage is go to np dot random dot rand int, press a question mark and enter. What this will do is this will give you all the description of the inputs. So the first one is low, second one is high, third one is size. Size means how many numbers do you want. Make sense?
Okay, sir.
Okay. Anything else?
Yes, one more question, sir. Sir, when we learn this, will we also be learning how to handle end-to-end capstone project by some sample.
Yeah, we will take different case studies for each of them. Yeah. Did I answer your question? So, okay. Now, moving on to the topic that we are going to study today, it is basic statistics. Now, basic statistics has the following parts to it. So first we'll start with the really basic of statistics, which is probability. We'll understand what is probability and some of the related concepts. Then we will go into what do we mean by distributions. Then we will talk about different parameters of a distribution. And after that, we'll talk about estimation and hypothesis testing. So this is the broad outlay of the basic stats topics that we are going to cover. Now to start with the first one, which is probability. Now all of you have, I'm sure, have heard about the term probability, right? So what is probability?
Probability is to find the number of outcomes.
The possibility of the outcome.
Yeah.
Of an
So
event.
chances or
The number of possibilities of outcome.
possibility
Of occurrence.
of any particular outcome. Right. So probability is usually probability number is usually corresponding to one particular outcome. So when you toss a coin, you talk about probability of either head or tail, not both, right? So it's one of the outcomes. Make sense? If you roll a dice, you talk about probability of one of the outcomes. Maybe probability of getting a 1 or maybe probability of getting an even number, right? So if we calculate probability from the mathematical sense, a probability number is basically number of favorable events divided by total number of events. Right? Number of favorable events divided by total number of events. So what do we mean by favorable events? Favorable events are those which you are actually looking for. Say for example, when I toss a coin, I want to get probability of head. So favorable events for me becomes head. If I am rolling a dice and I want to calculate probability of getting an even number, then favorable events all become all the even possible outcomes which have even numbers as the outcome, right? Similarly, if I randomly select one card out of a set of cards, all of you know how the cards work, right? 52 cards, 4 different types of cards, 2 different colors, right? So given a color and a type of card, there are only 13 cards. Okay, so if I am drawing, let me take an example, right? If I am randomly drawing one particular card from a stack of 52 cards, what is the probability that I'll get a card which has a black color on it? Okay, so what I'm saying is probability is usually represented by P. Okay, probability of black
It should be 1 by
colored card out of all possible cards in the stack of 52 cards, right? So the probability will be, so how many colors are black, how many cards are black in color? 26. So favorable outcomes become 26, number of all possible outcomes 52. So the outcome becomes 0.5.
Right.
Make sense? Okay. Now, what is the probability that I will get a queen if I randomly draw a card from a stack of cards? So how many queens are there? 4 divided by how many cards are there? 52
52.
divided, so it becomes 1 by 30. Make sense? Okay. So all of you are clear on this basic calculation, right? Okay. Now, probability as a mathematical calculation has the following properties. What are the properties? Probability should always be greater than equal to 0, and it should always be less than equal to 1, right? So probability will always be between 0 and 1. It can never be less than 0 or more than 1. Now, since it's restricted between 0 and 1, it is also often represented as percentage, right? So 0 stands for 0% and 1 stands for 100%. Makes sense to all of you? Yeah. Okay. So what is 5%? 5% will be 0.05, right? Remember this 5%. 5% is a very important term in basic stats. Okay. So these are the two most important properties of probability, right? Now, so we learn how can you calculate probability and what are its property, but why do we need to calculate this? I mean, it's not just a number, right? They must have some sort of utility. That's why probability is so important, right? So what does this number tell us? Prediction. Prediction is more of an outcome or a byproduct that you get, right? But what does it actually tell us? So let's take an example, right? Let's say if I ask you what is the probability that the Delhi team will win the IPL this year, right? Or let's say what is the probability if the Delhi team plays against Mumbai team that it will win? So you'll tell me a number. Give me any number. 50%. Okay, let's say you say that probability that Delhi will win is equal to 0.5. Yeah. So where is this number coming from? This number should ideally, if you would have thought about your answer, what you would have done in your mind is you would have tried to remember how many matches do you remember between Delhi and Mumbai, right? So it becomes number of matches between Delhi and the Mumbai team. Let's say you remember probably around 10 matches, right? And then you remember how many matches did Delhi won, right? That probably came out to be somewhere around 5, and therefore you told that probability that Delhi will win this match is 5/10 is equal to 0.5, right? This is what would have happened. Now, having looked at this calculation, tell me what is this number telling me? This number is basically summarizing your historical experience, because otherwise you just had 10 data points, and looking at 10 data points and getting to a conclusion with all the 10 data points without summarizing them is difficult. So what you do is you calculate one number which summarizes the outcome of all the 10 matches, right? So probability is a number which is basically summarizes your historical experience. Now, if you can summarize your historical experience, and if you can assume that history will repeat itself, then you can use that probability to predict as well. Make sense? So for example, if this number was not 5 but was actually 2, then how much will this probability be? This will probably be 0.2.
0.2.
Right? Then you could have said or predicted that Delhi will probably lose this match, right? Because you expect that history will repeat itself. So prediction is a byproduct that you get out of probability if you assume history will repeat itself. If history does not repeat itself, then probability cannot be used for prediction. Make sense? Okay. Now, remember this fact that history will repeat itself. If history does not repeat itself, there you cannot do any prediction. All prediction algorithms work on the underlying assumption that whatever has happened in the past will also happen in the future with minor aberrations. Okay, cool. So probability basically helps you to summarize your previous experience. All of you agree with this? Okay, now let's move on to some of the concepts which are very commonly used in probability. Let me open up a slide. All of you are familiar with Venn diagrams? Is there anybody who is not familiar with Venn diagrams?
I heard of it.
Sorry?
I heard of it.
You heard of it, okay. So Venn diagram is a mathematical way of representing events. So let's take an example. Let's say okay, let's say you are going to a party, right? And now in that party, there are two options of food. One is soup, and second is ice cream. Okay, so you have two choices, soup and ice cream, right? Now, there are 10 people who only ordered ice cream. There are 15 people who ordered only soup. And there are 5 people who ordered both. So in this Venn diagram approach, what this circle is showing, the circle to the left is showing set of all people who have ordered soup. The right circle is showing set of all people who have ordered ice cream. The intersection, the area that lies in both, shows set of all people who have ordered both, right? This is the bottom line of a Venn diagram representation. Now, is it clear to all of you what this means? Okay.
Yes.
Yes.
Yeah. If this is clear, let's calculate couple of probabilities. What is the probability that a person will order soup? The probability a person will order a soup is how much?
15
20 by
upon
30.
15
20 by
25.
30.
20 by yeah, 20 by
20 by 30.
So,
30.
so it will be, so soup, probability of ordering soup is how many people, how many people are favorable outcomes? 15?
15 upon
5,
30.
Plus 5.
15 plus 5, 20. How many people
10.
are there in total? 30, right? So it
30.
will be 20 by 30 or 0.67. Make sense? Okay.
Right.
Now, what is the probability that a person will order soup and ice cream?
Both.
5 by 30.
Right. 5
That
by
will
30.
be 5
5
by
by
30,
30,
which is 1 by
1 6.
6, right? Okay. Now, all of you are clear on this calculation? Yeah. Okay.
Yes.
So tell me, what is the probability that a person will order soup given that he or she ordered ice cream? So what is the probability that if you go to a person and you know that he or she has already ordered ice cream, what is the probability that he or she will order soup again?
5/10.
How much? Okay. So the
5/15.
probability is, so I have already told that he or she has ordered ice cream, right?
5/15.
So how many people ordered ice cream? 15, right? Out
Right.
of that, how many people ordered soup? 5. So
5.
this becomes 5 by 15, which is 0.33.
So can you repeat the question?
Yes.
The question is, what is the probability that a person will order soup given that the person has already ordered the ice cream? So your basis becomes all people who have ordered ice cream, right? How many people have ordered ice cream? 10 plus 5, 15. And out of that, how many people ordered soup? 5. Make sense?
Okay.
So
Yeah.
you are clear? Why is it not 20? Okay. Okay. So this is clear to everyone, right? Okay. Now let's look at this probability and let's understand how this is calculated, right? So in statistics, whenever I'm saying, let's say S represents soup and I represents ice cream. So whenever I say soup given ice cream, it is usually written as S slice I. So this slice represents given. Okay. This I here is known as a prior event which has happened prior or previously. The S is known as posterior. Prior means it has happened in history, posterior means it will happen after, right? So I am saying that he or she has already ordered ice cream. So it has happened prior, right? Previous to this soup happening, right? So ice cream became prior, soup became posterior. Okay. Okay. So if you have any probability which looks like this, which is A given B, this PS given I is basically 5 by 15, right? Now, can I write this 5 as 5 by 30 and the 15 as 15 by 30? Still it remains same, right? Yeah. Okay. Now, what is 5 by 30? 5 by 30 is basically probability of soup and ice cream. Yeah. Okay. And what is this 15 by 30?
PI.
Probability of
Outcomes. For those who order soup.
Ice cream.
ice cream, right? It's 15 by 30. How many? What is the probability that a person will order ice cream?
Right. 15.
15 by 30, right? Make sense? Okay. So what we'll do is we'll generalize this statement. What we write here is, given any two events A and B, if I calculate probability of A given B, it will be equal to probability of A and B divided by probability of B. A and B means both the events has happened. Intersection, yeah. In the Venn diagram, it is intersection. Yeah. Okay.
But sir, on the place of P, B, there will be a number of the total number of outcomes, na?
What? So do you agree with this line?
Yes.
So instead of S and I just wrote A and B.
Okay.
Yeah. Is this clear to everyone? Okay. Now, let's look at a theory which is known as Bayes' theorem, which is based on this expression. Okay. Now, I'm saying that probability of A given B. No, okay. Before we go into there, right? So, do you all of you agree that probability of A and B is equal to probability of B and A? Don't agree? Okay. So what is probability of soup and ice cream both happening? So you have written here, right? 1/6. What is the probability that a person will order ice cream and soup? 1/6. Yeah. So it's same, right? Yeah. Okay. So A and B and A are same, right? Okay. Now, so let's start with probability of A given B, right? We know that it can be written as probability of A and B divided by probability of B, right? What I just do is I switch this A and B because we know A and B is same as B and A, right? So I just write probability of B and A into or divided by probability of B. It still is equal. Yeah. After this, what I do is, now again, before we take the next step, I just want to make sure if I have a ratio which is A by B, right? Do you think that it will be equal to A by C divided by B by C? Yeah. All of you agree with this? Yeah.
Yes, sir.
Okay. Now, what I do here is, this is also a ratio, right? I divide the numerator and the denominator by probability of A. Scroll up. Okay. So what I do is, this is again a ratio, right? So this is a ratio, right? I divide the numerator and denominator by probability of A. So what happens to the numerator? The numerator becomes probability of B and A divided by probability of A. This becomes the numerator, right? And the denominator becomes probability of B divided by probability of A. Yeah. Now, tell me what is this? This is B given A, right? So this is probability of B given A into probability of A divided by probability of B. Make sense? What is this? This is probability of B given A, right? So I just wrote probability of B given A, right? And this is in the denominator, it is probability of B by probability of A. If I bring it to the numerator, it becomes reciprocal. So it becomes probability of A by probability of B. Where? How does this in? It is coming from A and B, right? A and B is same as B and A. So I just kept it B and A. Do you agree with this? Yeah. So what I did was this was also a ratio, right? This is a ratio, right? I divided the numerator and the denominator by probability of A. The ratio remains same. Okay. So Bayes' theorem is finally this. Bayes' theorem says that probability of A given B is in fact equal to probability of B given A into probability of A by probability of B. Right? So this is a groundbreaking theory in statistics which helps you to go from a prior to a posterior. So what you see is you are basically reversing prior to posterior and posterior to prior, right? Now where is or how is this used? I will tell you a very daily use of this, which you use it but you do not know. So for example, if you want to have a really good food, right? Let's say you want to have really good dinner. What you usually do is, if you do not know the place, you go to a place which is usually very highly priced. Right? If you want to take somebody on a date to a very nice place which has good food, you will probably go to a place which is very highly priced. Why do people do that? The reason people do that is, so the only reason that you will do that is you will probably think that probability of having good food given high price is very high. Right? That's the only reason you will go to a high price place, right? Because given that you are paying a high price, the probability of getting a good food is very high. That's what you think. That's why you go to a highly priced place, right? Now, where is this coming from? This is coming from your historical experience. In your historical experience, you think about what is this probability? Probability of paying a high price given that you had a good food. If this probability is high, then only will you go for this, which is usually the case. Makes sense? This can be used in n number of business cases, right? Say, for example, you want to know what is the probability that I will succeed if I launch this product. What you do is you go back to history and figure out when did you launch something similar and what happened after you launched it. So you calculate the reverse probability, and which can then be used to get this forward-looking probability. Right? This is known as Bayes' theorem. Now, we will not refer to this theorem in a very will not very frequently refer to this, but if you are interested in AI, which one? This one? Yeah. So when, I mean, say for example, when will you choose to go? Oh, this part, right? Okay. Oh, okay. So if you agree with this, right? Yeah. Okay. Can I write this in this way? Can I write it as A by C into C by B? Can I write it in this way? Because if you bring something from the denominator to the numerator, it gets reciprocal, right? So that is happening here. So we had in the denominator PB by PA, but when I brought it in the numerator, it became PA by PB. How can I give an A? Okay. What is this? Okay, let me put it into different lines. Then you tell me which is the line number where you have problem. Line number 3. Okay. This. Yeah. Dividing, not multiplying. I'm dividing the numerator and denominator by probability of A. I am dividing, basically I'm multiplying it by P of A, but I am taking the numerator to denominator and denominator to the numerator, so it becomes division. Don't think of it as a multiplication. Let's say you have a ratio 2/3, right? Is 2/3 is equal to 2/2 divided by 3/2? Equal, right? So I am exactly doing that. Let's say this ratio was 2/3. What I've thus done is divided by the same number in the numerator and the denominator. PA, right? Yes. No, I have divided the numerator by PA. I have divided the denominator by PA. So the ratio remains same. How come that? Okay, so what is this? Look at this line. Look at this line and tell me what is this? B given A, right? So the numerator becomes B given A, right? And the denominator is PB by PA. Okay, so I have actually skipped one step, right? So what I should have written here is probability of B given A divided by probability of B divided by probability of A, right? Now what I do is I bring this quantity in the numerator, so it becomes reciprocal and becomes PA by PB. Make sense? Okay. Now, did you understand this, or did you have a question on this as well? This? Okay. So here what I'm saying is, why do people usually go to highly priced places if they want to have a good food? The reason being, the probability of getting good food is really high if you are paying high price. So this probability is very high. Now, how can this probability be high? This probability will be high if this quantity is very high. Now, what is this quantity? This quantity is probability that you will pay a high price given that you had a good food. Usually that probability is very high, right? And since this is very high, that's the reason this is also very high. Make sense? Okay. Yes, so what I was saying is, we will, for this course, will not go into Bayesian statistics a lot, but if you are really interested in AI, Bayesian statistics has a huge application in AI, right? So please feel free to read about it and get more familiarized with this, right? But for this course, this is a Bayesian statistics is not part of this course. AI is, so think about it, right? Say, for example, if you would like a computer to take the decision of going to a restaurant or not, you would like to build in this logic into the computer, right? So you would be using Bayesian theorem to build into the decision-making capability to the computer. Because most of the human decisions that we make are can be shown to be based on Bayesian equations. Right? Think about, give me any scenario, I will tell you it is based on your experience. Why do people, when you touch fire, before touching fire, why do you come out of it? Because sometime in past, you would have touched fire and you would have felt that that is not a very nice experience. So given a nice experience, the probability of touching a fire is very low, right? So that's why you move up, right? Okay.
Sir, basically Bayes theorem will use in predictive analysis, right?
No, a Bayes theorem will not be used in the predictive analysis for this course. But if you are interested in AI, pure AI, then Bayesian theory is really important.
Okay, cool.
For this course, this is the only time that you see this theory. Okay. Yes, yes, two events. Events, yeah. Yeah, absolutely. I mean, what is the, if I talk about probability of raining today and you waking up early, they're not related, right? Or maybe they are, I don't know. Okay. Yeah, it might happen. Yes. Anything else on this? No, right? Okay. Now, so this is what I have in terms of talking about probability. Any question on probability? Couple of things that you should only remember here is these two lines, and that's about it. Okay.
But
Everything else?
sir, I do have a question.
Yes.
As you have given the example of Mumbai and Delhi match, and you predicted that there is a, I mean, 0.05% is the chances to win Delhi. So I think this is the predictive analysis, right? You are predicting what will happen in future. So don't you think probability will use in predictive analysis?
Oh, probability we will be using. What I told was we will not be using Bayes theorem particularly.
Okay, got it.
Yes. Any questions? See, just to simplify for the people who are not familiar, just remember these two lines. Okay. That should be okay.
Sir, can you explain these two lines once?
Probability is always between 0 and 1.
Okay.
And probability can also be expressed in percentages.
Okay.
Yeah. Okay. Now, the next concept that we are going to talk about is distribution, right? So what do we mean by distribution? We will do this, we will talk about this by using an example. So let's say you are working for a client and the client is a ice cream vendor, right? The client is an ice cream vendor, let's say Baskin Robbins, right? They have opened a store and that store has only one window. One window means they can only serve one customer at a time. Make sense? Okay. Now, the business owner has received some input saying that he should open up a new window. And because the customers have to wait for a long time to get served. This is the input that he or she has received, right? So in order to figure out whether he or she should open up a new window or not, he or she wants to do some sort of analysis on the customer data. Make sense? Because you see, opening up a new window has a lot of investment, right? You have to employ somebody, you have to buy new machineries for it and so on, right? So before making that investment, that person wants to be sure that the investment is indeed required. And they have hired you as the analyst to figure out, right? Or to basically make some sense out of the data, right? Okay. Now, remember, as an analyst, your job is not to take the business decision. Your job is to just report what you see in the data, right? You will not take the business decision, always. Okay. Now, so if you are the analyst, what is the first thing that you will do? Get data, right? Get data, because if you don't have data, what will you analyze, right? So what you do is, let's say, you go to this store for 10 days in a particular time, and you note number of customers standing in queue, right? So say, let's say, for example, on the first day, you note there were 0 customers standing in queue. Second day, there were 2 customers. Third day, there were 3, then 2, then 5, 6, 4, 2, 2, 0. Let's say this is the data that you have got, right? Now, what should you do? Should you just show this data to the owner? You should not, right? You should ideally summarize the data, right? Summarization of data, especially this kind of data, can happen in two ways. Either you summarize using numbers or you summarize using graphs. Make sense? Okay. One of the ways of summarization is by using a particular type of graph known as bar plot or histogram or frequency plot, right? What you do is you basically calculate the frequency of the number of people standing in queue. Now, what do I mean by that? So let's say you note the number of people standing in queue. What are the numbers? 0, 1, 2, 3, 4, 5, 6, right? 6 is the maximum. These are all possible values. Make sense? So imagine this queue being a black box. Every day you open up a box and you get a new number, right? Now, what are all possible numbers? These 6 numbers, right? Okay. Now, then what you do is you plot the frequency. How many times did you see 0? 2. How many times did you see 1? 0. How many times did you see 2? 3. 4. How many times did you see 3? 1. 4 is also 1. 5 is 1. 6 is 1, right? So this should sum up to 10. Yeah. These become the frequencies, right? Now, if you plot these frequencies, this plot is known as frequency distribution. This shows you how are the frequencies distributed across different values of this queue. So this is a very convoluted way of looking at it, but this is how people look at it in statistics. Why? 0 is not there. Okay, there is 0. Okay, I have not chosen the x-axis, right? So choose the x-axis. Zero is there. I have not chosen that axis. Yeah. Yes, this shows that frequency of this value 0 is 2. Frequency of 2 is 4. No, we have not done binning. So this graph is known as frequency distribution, right? And in the x-axis is known as a random variable. Now, this is a concept which is very hard to digest, but this is how it is, right? So in statistics, everything is termed as a variable, right? Now, the way you should understand this is, this Q is a column in Excel, right? Now, what you should imagine is, let's say this Q is coming out of a machine, right? It is a machine which every day is giving you new numbers, right? And this machine is known as a random variable. The reason being, you assume that these numbers are chosen under some sort of randomness. That's how mathematics usually work. So what mathematics, everything is either a process or a machine, right? So this people standing in queue is a process. The only part of the process that you see is the number of people standing in queue, which is the outcome, right? What are all possible outcomes? All possible outcomes are 0, 1, 2, 3, 4, 5, 6. These are all possible values of the outcome. What you have just done is plotted the frequency of each of the outcome, right? Imagine you are rolling a dice which has 7 faces, 0, 1, 2, 3, 4, 5, 6. And every time you roll, you get one of these faces. So the first time you rolled that dice, you got 0. Second time you rolled it, you got 2. Imagine this as some sort of a process where you are rolling a dice and getting a number, right? Now, this frequency plot then becomes the distribution of the values. Make sense? Okay. So this is known as frequency distribution. Now, along with frequency distribution, there is also another concept known as probability distribution. What you do is you just divide the frequency values by the total. Right? So what is the total here? 10?
6.
Total is 10. So you divide everything by 10 and you again plot that. What you get is probability distribution, because now these bars no longer show you the frequency, but rather they show you probability of getting that value. Graph will look same, but the values have changed. Previously it were like 4, 5, 6. Now it is all between 0 and 1. They will look exactly same. Yeah. Make sense? Okay. So this is the concept of probability and frequency distributions. Okay. Now,
Sir, I have a question. I mean, where we use probability distribution and where we use frequency distribution?
We will always use probability distribution.
So, okay.
So we divided by 10 because number of days are 10.
Yes.
Okay.
Excuse me, sir, I have a question. Is there
Why
any
is the probability not summing to 0? The probability will always sum to 1. So then we are missing something here. Oh, I have not done it for all. Yeah.
Sir, I have a question.
Yes.
Is there any exception when probability distribution is different from frequency distribution in the way it's seen, as in the graph mode?
No, never, right? Why will it be?
Yeah, so it's
Never.
always the same, right? So
Yeah, it will always look the same.
there's
Because
no much-
basically you divide every frequency by the same number, right? So the graph looks exactly the same, but the scale gets reduced.
Okay.
Okay, so the way you should represent this data graphically is by using probability distribution. Make sense? The only thing that you remember from whatever I just said right now is what is this. So when I say probability distribution, you should be able to imagine there is some variable whose values have been plotted in the x-axis and their respective probabilities have been plotted in the y-axis. Okay, so when I say distribution of ages of Indian male looks like this. Say for example, if I draw a distribution, right? And I say this is the distribution of age of Indian male. What is there in x-axis? All possible values of age, right? So it should start at somewhere around 0 and it'll continue till somewhere around probably 90, right? Yeah. And what is in the y-axis?
number of people.
Probability. This is probability distribution.
Probability of getting.
So if I want to know what is the probability that if I select an Indian male randomly, he will be of age 25. What will I do here? I will go to the value 25, get a line to go up vertically wherever this touches this point, go to the left. This gives me the probability that a person selected randomly turns out to be of age 25. Make sense? Okay. This concept is clear, right?
Sir, I have a question.
Yes.
As you have given us the example of means, should owner open a new window or not? So according to data and probability distribution, can we answer for this question? I mean,
no, again, like I said, your job is not to tell him or her that whether they should open a window or not. Your job is to represent the data in the most understandable way possible.
Understand, sir, understand. But can we answer from data? I mean, apart from our job, can we answer from the probability distribution for
You
this?
can. If you have enough domain knowledge, you can. Say, for example, this is the probability distribution, right? Okay, let's draw another probability distribution. Let's say this is a probability distribution. In the x-axis, I have number of people standing in queue, right? In the y-axis, I have the probability. What I can do with this graph is, I will look at this value, right? Let's say this value is 0.2, right? And let's say this value is 3. Okay. So what I can infer from this distribution is probability of having more than 3 people standing in queue will always be less than 0.2. Make sense? Now, if I as a business person, if I have enough domain knowledge to figure out whether this 0.2 is low enough, then I'll decide not to open this new window. If I think that this 0.2 is really high, then I'll probably open a new window. Because having 3 customers standing in queue is normal, right? Let's say I have that domain knowledge. My concern is having more than 3 people standing in queue. If that probability is really low, and I know what I mean by low and high under the business scenario, I will be able to take a call whether to open a store or not.
Fair enough.
Right? But people in analytics usually A, do not have the domain knowledge, B, nobody will listen to you if you talk about domain knowledge, right? Because that's not your field, right? It's not your job to do it, right? So you should probably stop somewhere around here.
Fine.
Okay, so you can represent the data using probability distribution. Now, the second way of representing data is through numbers, right? Now, what do you mean by numbers? Probability distribution gives you a picture, right? Now, oftentimes people are not able to get the larger picture from the graph, right? So you have to give them solid numbers. Now, the numbers that are typically given to describe our distribution are 2 things: central tendency, and the second number is dispersion. Now, what do we mean by central tendency and dispersion? Now, let's say you have this distribution, right? This is a distribution, right? Now, by looking at this picture, let's say you are not able to understand what this means. What this central tendency and dispersion will do is, they will tell you what is the most common value or the middle point of this distribution, and dispersion will tell you what is the spread of this distribution. So if I know the middle point and the spread, I will get a good idea about the distribution. We'll come to that. So if we know the middle point and the spread, I will get a good idea about the distribution, yes or no? Yeah, there are other properties as well, but these 2 are the most important.
You are talking about the middle point or the highest point, because here it looks like
same, I guess.
What do you mean by highest point?
highest point, not the middle, right?
What do you mean by highest? Highest point is the one which is at the right, right? Because the value is
Like highest means in terms of probability highest, actually.
Oh yeah. So if you talk about high in terms of probability, central tendency can do both, right? It can give you the middle point. It can give you the point with highest probability, and both as well, right? We'll talk about that.
Actually, the middle point might not be having highest probability.
Yeah. So there are different measures of central tendency. I'm not talking about a single measure. Okay. Now, central tendency typically has 3 measures. The first one, all of you have heard about this, is known as arithmetic mean or average or mean, right? The second measure of central tendency is median. And the third measure of central tendency is mode. Now, arithmetic mean, all of you understand, right? Arithmetic mean is basically sum of a particular variable divided by n being number of observations, right? So whenever I write x, it basically means some variable. Imagine something else, right? Age, height, weight, whatever. Median. Now, median is basically the middlemost value, right? Now, what do we mean by middlemost value? For example, these are the values of the variable q, right? What I do is, if I want to find the median, let's say I have 11 observations. So if I want to find the median, what I do is, I will sort this value either from largest to smallest or smallest to largest. Okay. Now I have 11 observation. What number of what is the observation number which is exactly in the middle? 6, right? So what I do is I go and look at the 6th observation, and the 6th observation is the median. So median is exactly the central observation in all the values that you have. To calculate median, what you just need to do is sort the observations from largest to smallest and take the middle one. Now, what if you have even number of observations? Then you will not get a per middle, distinct middle, right? So then what you do is you divide, you take n by 2 and n by 2 plus 1th observation and take their average. So for example, if I have 10 observations, median will be basically average of 5th and 6th observation. Because there is no distinct middle if you have even, right? Makes sense? Okay. So arithmetic mean is basically pointing out to a typical value that you expect to see, right? Median is pointing out to exactly the middle value that you are seeing in the distribution. Mode is pointing out that value which is most frequent. For example, in this particular case, this is the mode, because you see for this particular point I have the highest probability. So mode is that point or that value which is most probable to occur, right? So if I talk about mode of gender in India, what will that be? Male, right? Because our population distribution is skewed towards male gender, right? Okay. Which one? Mode? Okay. Mode is that value which occurs most frequently. Say for example, if I talk about this, which value occurs most frequently? 2, right? 2 occurs highest number of times. So 2 becomes my mode. Similarly, if I talk about a categorical variable like gender, right? Which gender occurs most frequently in India? Male. So male becomes the mode of the variable gender. Yes. If 2 values occur the same number of times, take average. If say 2 comes 4 times and 5 comes 4 times, take average. Yeah. So your mode will be 3.5. Make sense? No, average of the values. Say for example, if 2 occurs 5 times, 5 occurs 5 times. So these are the only 2 values which are most frequent and they are equally frequent. Then your mode becomes 2 plus 5 divided by 2, 3.5. Make sense? Okay. But typically, when we have 2 modes, we will refer to those distributions as bimodal. We will not take an average. We will say mode exists in 2 values. Okay. So central tendency, yes, gives you the idea of three things. A, what is the most typical value? B, which one is the middle value? C, which one is most frequent? Make sense?
So in case
Yes.
6 encountered one time, 5 2 times, and 4 again 2 times, then
Yeah, so that's what I said, right? If you have multiple values occurring the same time, take an average.
oh yeah, yeah. Okay.
Sir,
Okay.
I have a
Yes.
question. In graph that you have shown, can we talk about left skewed and the right skewed? I mean,
We'll come to skew later, right?
okay.
Okay. Now, dispersion.
So there is a distribution, I mean, for mean, mode, and median. On chart, we actually have seen somewhere that you can mention that median lies in middle and mean lies on left and mode lies on right.
Sorry. In what?
In this chart, can we mention that mean, mode, and median by position, which one will like first, then second and third? I've seen somewhere that there is some chart for the same thing.
No, in this particular chart, mean is exactly equal to median, exactly equal to mode. In this particular chart. But there is no order to it, right? It will depend upon what kind of distribution you have.
Okay, thank you.
Okay, so right now, understand this fact that central tendency in general talks about what are the central values of a distribution, right? Dispersion, on the other hand, talks about how different are those values. Say, for example, if I talk about the average of this variable, so the average of this variable will be 2.5, right? The median will be 2 and the mode will also be 2, right? Now, if you just go to the business with these numbers only, what they might ask is, do you think all the values are 2 or 3? Because you were saying in arithmetic mean, you were saying our generic value is 3, the middle value is 2, and the most frequent value is 2. They might ask you that are all the values equal to 2 or 3? So there comes the concept of spread. So how different are these values with respect to the central tendency? Central tendency gives you the central value, but are all the values equal to the central value? No, values are different, right? So dispersion tries to quantify how different are those values. One of the measure of dispersion is range. Range is what? Maximum value minus minimum value. What is the maximum value here? 6. Minimum value 0. So range becomes 6. Make sense? Okay. The second and the most important measure of dispersion is known as standard deviation. But before we go into standard deviation, does all of you understand what I mean by arithmetic mean, median, mode, and range? Okay.
Can you please repeat range again?
Range is maximum value minus minimum value.
Okay.
Make sense? Okay. Now, standard deviation, right? So,
Sir,
yes.
Can you repeat dispersion?
Dispersion is the generic term which basically is used to represent the measures that quantify how different are the values. For example, central tendency is the terminology used to mention all of these three matrices. Dispersion is the term which is used to measure how different are the values.
How different the value means? I couldn't able to get it, I'm sorry.
No, for example, central tendency gives you a point, right? So central tendency tells you that the central point is at 2, somewhere here, right? But are all the values equal to 2?
No.
No, right? So therefore, we need to know how different are rest of the values. I understand that the central value is 2, but I also need to understand how different are the rest of the values.
From 2.
From 2. Then only you will get an idea that of the whole distribution, right? 2 gives you the central value, but until and unless you know the spread of the distribution, you will not be able to understand the whole nature of the distribution.
Cool, thanks.
Okay. Now, standard deviation is a bit convoluted measure, but there is a solid logic behind this. So in order to calculate standard deviation, what you first need to calculate is average. Now, the primary thing that you should understand in any statistical measure is the logic, right? What is the logic behind it? Now, what I told you is dispersion is a measure which tells you how different are the values with respect to the central tendency, right? One of the most common measure of central tendency is average, right? So here we are going to learn how different are the values with respect to the average. That is the logic, right? Now how we can do that? So the first thing that we do is, which is the most intuitive way of learning the difference is difference. You take a difference of mean from every value, right? Okay. Now, so you take difference of every value from the mean. Right? So you get these values. Now, the problem is some of the values are negative, some of the values are positive. Both are different, right? Say for example, let's say my mean is 2. If I have a value 0 and I have a value 4, both are equally different from 2, right? But for one, I am getting a negative difference and for one, I am getting a positive difference. But for me, they should equally be treated, right? Both of them are of equal difference, right? So the problem with taking the difference is the sign, right? The sign unnecessarily differentiates between observations on two sides of the mean. Whereas for me, they are equally bad or equally good. Now, how do we remove the sign? Either you can take absolute or you can take a square. Absolute function is generally avoided in mathematics for a couple of reasons. A, it is not interpretable. B, it is not differentiable. You cannot differentiate an absolute function because it's not continuous. So we will not use absolute, but rather we will use square. So what we do is we square the difference, right? So here we say this to the power 2.
What do you mean by it cannot be differentiated actually? The absolute?
Okay, so the requirement of a function to be differentiable is that the function should be continuous. Now, if you look at the graph of an absolute function, the graph will look somewhat like this. This being 0. So at this point, it is not differentiable. But let's not go into differentiability, right? So do you agree that square is a method of removing the sign?
Yes,
Forget about
sir.
it.
Sir, you said continuous function. What does that mean?
Again, do not go into continuous function. Do you agree that squaring is a method to remove signs?
Yes, that is that.
Okay, now let's stick to that. Now, what I've done is I have squared this, right? Now I have differences on either side of the mean. Now I somewhat need to summarize this, right? Because now I have 10 observations, right? I need one number. So what is the easiest method of summarization? Average. Average is the easiest method of summarization, right? So what I do is I take an average of these squared differences. Comes out to be 3.16. Makes sense? Okay. Now there is a problem. What is the problem? This Q was in a particular unit, right? What is the unit of this? Square of that unit, right? Because I am dealing with squares. Now I need to go back to the original unit. How do I go back? Square root. So what I do is I take a square root of this average. This is known as standard deviation. Okay. So standard deviation in English language is average of squared differences from mean and a square root over that. So square root of average of squared differences from mean. Make sense? Okay. Now, do you understand the logic behind all of this mathematical jugglery? The only logic was we wanted to understand how different are the values from mean. Make sense?
But the value which has come as 1.78
Mm-hmm.
is very realistic because the highest difference is 4, right? From 2 and 6. 2.5 and 6 is 3.5, but the standard deviation has come out to be 1.78. This is not looking very realistic, right?
I don't understand what you mean by realistic.
Okay, it is the average of differences, then it is okay. Okay, it's okay. It's okay.
Sir, we have done a square root because we want the result in same unit, right?
Yes, yes, yes. Yes, yes. For a given set of observations, standard, basically for a given distribution, one standard deviation. Okay. Okay. So if I write the formula for standard deviation, it is square root of average of this quantity value minus mean to the power 2. Huh. We will come to that. For now, you understand the measure of the method of calculating standard deviation. Okay. Now let's understand what we mean by that, or how can you interpret the standard deviation. You will see that most of the observations will lie between mean plus 2 standard deviation and mean minus 2 standard deviation, right? Or in fact, I mean, if you even take mean plus minus 1 standard deviation, you will get most of the observations. So what is my mean? 2.5, right? So 2.5 plus 1.78 is how much? So 2.5 plus 1.78 is 4.32, and 2.5 minus 1.78 is 0.77, which is like 0, right? So you will see most of the observations are between 0 and 4. Few observations are over and above, over or below that. Make sense? You see most of the observations are captured here, right? Between 4.32 and 0.77, how many observations do you capture? You capture all of this. It is bulk of the observations. Yeah. So standard deviation basically gives you some sort of a range by within which you will see most of the observations to occur. Now, depending upon what is the underlying probability distribution, that percentage might change. Right? We will talk about this in detail when we talk about normal distribution. We'll talk about this in detail. Okay. So central tendency gives you the central point, dispersion gives you the spread. Now, using these two numbers, what can you report to the business? You can tell the business that typically, see, we get around 2 to 3 people in our queue, right? But they might vary by around 2 number of people, right? So I just rounded it off, right? So typically you get 2 to 3 people standing in queue, but plus minus 2. You can get plus minus 2. Make sense? Yeah. Oh,
Yes,
4.32 is mean plus standard deviation, and 0.7 is mean minus standard deviation. 2 to 3 people, it's 2.5, right? You cannot have 2.5 people standing in queue. So it's 2 to 3. So typically the business, I mean, you can tell the business that typically 2 to 3 people are seen in queue with a variation of plus minus 2.
So
Yeah.
this
With the
2.
usual variation of plus minus 2. Yes. Yes. Plus minus 2 is the standard deviation.
So this 2.54 is mean of 0 to 6.
Yes, 2.54 is the mean of all of these values.
Okay.
Yeah, obviously, I mean, you cannot tell the business, I expect 2.5 people standing in queue, right? कौन से numbers? Oh, I mean, okay, forget about these two numbers. We will come back to them when we discuss normal distribution, तभी clear हो जाएगा. Okay, अभी के लिए भूल जाओ आप. अभी के लिए मेरा, the point that I wanted to make is, bulk of the observations will lie between mean plus 1 standard deviation and mean minus 1 standard deviation. Makes sense? That's why we say that 2 to 3 people standing in queue with a usual variation of plus minus 2. You will never say with a confirmed variation. You will say usual variation. Because there are observations which is beyond plus minus 2, right? Okay, makes sense?
In terms of interpretability, we are missing out the days where 5 and 6 people were.
Yeah. I mean, see, in any analytics, you will talk about bulk of the observation. There will be observations which are outliers, which have abnormally high or abnormally low values. You can never consider them. So we will talk about bulk of the observations always.
Okay. Okay, fine.
अरे हो सकता है ना, यहाँ पे कुंभ का मेला लग गया, बहुत सारे लोग हैं, क्या कर सकते हैं उसके लिए?
हो सकता है.
हाँ. Right. Because 1.78. Yeah. Okay, what was your question?
Sir, I have a question.
One second, I'll come back to the online question. What is your question? .16 is the average of the square differences. I took a square root of 3.16. Yeah. Yes, what was the question from online?
Sir, we always do plus minus 2 on variation.
No. Here I have got the standard deviation of 1.78, right? So I rounded out to 2.
Okay. And sir, another thing, we can say standard deviation is basically a square root of variation.
Yeah. So if you do not square, so there is another term called variance, which we will probably never use, which is this, which is square of standard deviation. But we will always talk about standard deviation, never about variance.
Cool. Thanks.
Yeah. Okay. Now, before we go on to break, one last concept that I want to cover is the concept of coefficient of variation. COV stands for coefficient of variation. Now, which one? 3.16 is not a variance. The variance is standard deviation. 3.16 is square of standard deviation. Oh, no. The name of this measure is variance. This is the name that has been given to this number. 3.16 is known as, the name is variance. And the name of this 1.78 is standard deviation.
So is there any benefit of variance in terms of interpretability?
No, variance is not used. Yes.
Yeah, because it is not making any sense to us.
The name, the mathematical name is variance. It has nothing to do with how the observations are varying. Variance is square of standard deviation. I'll come to it, what domain it comes into. Any other questions on central tendency and dispersion? Mean plus minus 1 standard deviation. Yeah, always, yeah.
All good.
Sir, where do we use range?
See, now you will whenever you talk about dispersion, you will typically be talking about standard deviation. Range is something which is not used that much. I mean, it is also another measure, but it is not used that much.
So there is no significance of range.
Yeah, you will probably be making your decision on bulk, right? So you will probably concentrate on that. Yeah, I'm sorry. Range is something which we will not use. Range has a significance. It basically tells you what is the difference between maximum and minimum, but it typically is not used in any analysis because it does not relate back to central tendency. Okay. Typically, this and this are used, right? Under certain scenarios, these are also used. We'll talk about those scenarios later. Okay. Now, let's talk about coefficient of variation. Now, to understand coefficient of variation, we'll use an example, right? Let's say there is a factory that manufactures two things. It manufactures iron rods and it also manufactures needles, right? Now the ideal size of the rods should be 1000 centimeter. The ideal size of a needle should be 10 centimeter. This should be the ideal size, right? Okay. Now the factory has been operating for a long time and the machines that manufacture both of these have received a lot of wear and tear. As a result, what is happening is now the rods are coming out, certain rods are coming out to be having less than 1000 length, certain rods have more. Similarly, the aberrations are also happening for needles, right? So the accuracy has reduced. Now, the owner has decided to replace these machines, right? But he can only replace one machine at a time. He has enough fund to buy and replace only one of the machines. Now he has to prioritize which of these two machines has to be replaced. In order to prioritize, what he did was he randomly selected 10 rods and 10 needles coming out of the machine, and he found out that the average length of the rods, those 10 rods, was 1000 and the standard deviation was 10 centimeter. Make sense? Okay. Similarly, he found out for the needles as well. He found out the average size was 10 centimeter and the standard deviation was also 10 centimeter. Right? Now, having looked at this data, what should he decide, or which machine should he replace first?
Obviously needle.
Okay. Why?
Because the standard deviation is too much as compared to the
Variants are exactly same, right? If I just look at the variance column, they're exactly same. Yes. So what you are essentially doing is you are essentially looking at standard deviation with respect to the mean, right? This is exactly what is done is coefficient of variation, right? Coefficient of variation, or COV, is basically standard deviation divided by mean into 100. Basically, it's expressed in percentage. what percentage of the mean is standard deviation? This is known as coefficient of variation. What percentage of mean is standard deviation is known as coefficient of variation. Now, why is this calculated? This is calculated because you cannot compare standard deviation of one variable with another variable, right? Say for example, if I talk about standard deviation in height, it will be in centimeters. If I talk about standard deviation of income, it will be in thousands. I cannot talk about these two standard deviation and or I cannot say that the height of Indian males are more varied than their income. I cannot comment like this, right? By just looking at the standard deviation. But if I divide it by their mean, I can then comment. If the coefficient of variation of height is less than coefficient of variation of income, then I can say height is less varying as compared to income, or vice versa. Make sense? The reason being, first of all, you are basing it around mean, so it gets normalized. Second of all, this unit becomes, this coefficient of variance, this measure is unit free. Because if you think about it, standard deviation has a unit of centimeter, mean has a unit of centimeter. Divide both of them, units gets cancelled out, you get a pure number. So I can compare measures in different units using coefficient of variation, but I cannot compare them using standard deviation alone. Make sense? Okay. Exactly. So if you wanted to compare variables which are either in different units or coming from different contexts, you will have to use coefficient of variation. Right? Here, for example, although they were in the same unit, but their contexts were totally different, right? Where in one case, we were expecting the average size to be 1000. In the other, we were expecting the average size to be 10. The context was totally different, right? So the only way we can compare these two contexts if we look at coefficient of variation. So coefficient of variation is the third measure of dispersion. Make sense? Okay. So what we'll do is we'll now go for a break of 10 minutes and we will start around 3:55. Now, so far what we have understood now till here is, now help me understand whether all of your family are okay with these topics, right? So first one is probability. All of you are fine with this?
Yes.
Second, distribution. All of you are fine with what is a distribution? Basically, you need to remember what is in x-axis, what is in y-axis. That's it. Okay. Third, central tendency. Yeah. And fourth, dispersion. Now, in central tendency, most important is mean. In dispersion, most important is standard deviation, right?
Yeah.
Okay.
Sir, central tendency means the central limit theorem, right? The same, just and the same.
No, central tendency we talked about, right? Central tendency.
Yeah, right. Understand. But is it called the central limit theorem? The same?
No,
there is.
No, they're not.
Okay.
Okay.
Central limit theorem seems like the same when we are going to draw. It's like the same bump. What we draw.
Central limit theorem has nothing to do with central tendency.
Right.
Yeah. Next, the fifth thing that we are going to talk about are probability distributions and types, right? What is a probability distribution? We already have taken a brief look at it. Now we'll also understand what are the different types of probability distributions, right? But before we go into this detail, let's first understand why we need to study this, right? Why do we need to study these distributions? Now, when you are analyzing the data, what you typically do is to get to a distribution, you plot that graph which we did, right? We plotted one graph, right? A bar plot, right? If you plot that graph, you will get to the frequency as well as the probability distribution, right? Now, if you know the frequency and the probability distribution of a particular variable, what is the advantage? The advantage is you can draw conclusions like what is the most frequent value. You can say that say, for example, if I know the exact distribution of income in India, I can say that there is a 70% chance that you will get a salary between this and this, right? I can say that given your salary, how many people are earning less than you, how many people are earning more than you. I can do all of these things, right? Which basically I will be able to give you a lot of insight on that variable, right? If I know the distribution of a particular variable, I can give a lot of insight on that variable. Agreed? All of you agree with that, right? Now, so all of you agree that knowing the distribution it is good to know the distribution, right? Now, the problem is when you actually look into the real data, every time you will get a new shape. A distribution is nothing but a shape of the curve, right? Every time you will get a new shape. So for example, if I take the distribution of age, that will look totally different as compared to distribution of income, which will look totally different as compared to distribution of height. So for all possible data, if I get every time a new distribution, it is humanly impossible to know those distributions, isn't it? So what statisticians do is they use pattern matching. What do we mean by pattern matching? Pattern matching is very similar to what we do when we go to buy our clothes, right? So let's understand what they do and then we'll look at the analogy, right? So in statistics, what people have done is they have looked at some of the most common shapes, general shapes that you see in distributions, and what they've done is they've got mathematical equations for those shapes, and they have jotted down all possible properties for those shapes. So what they have done is they have taken 10-20 frequently occurring shapes and very well studied those shapes. Make sense? Yeah. So they have taken 10 or 20 shapes which are most frequently occurring, and they have studied those shapes very well. So if I get a distribution which is exactly like that shape, I will be able to get insights from it right now, because I know that distribution. Yeah. Okay. Now what they do is whenever they get a real data, they look at the real frequency distribution or the real probability distribution, right? And then they try to look at the known distributions, right? You have the real distribution and you have known 20 or 15 distributions, right? And then they figure out which of the known distribution matches the real distribution closest, right? This is exactly what you do when you go to buy clothes, right? When you go to buy clothes in a ready-made store, each human being is virtually of a unique shape. If you look at two human beings, they will be of a different shape. But do we have infinite variations of sizes in clothes? No. You have typically 4 to 5. So what do? You buy that shape which fits you the best. So here also we look at the practical distribution or the real distribution, but we will then match it to one of the known distributions. Now once I figure out that which of the known distribution matches my real distribution the closest, I will forget about the real distribution and continue with the known distribution. Say for example, once you know that the XL size fits you the best, you forget about your own body type and you only order XL. Make sense? So we will do exactly that in distributions as well. So we have noted down a list of a lot of distributions, and we will typically use one of those which matches the real data most closely. Yeah. Okay. Now, the most used or the distribution that you will use in 99.9% of the cases is known as normal distribution. This is the distribution which is used in 99% of the cases, and there is a mathematical reason behind it. We'll come to it. So the most used distribution is known as normal distribution. The other names of this distribution are bell curve. All of you heard about bell curve. People who work, they know in rating cycle, they fit in bell curve, right? Sorry? क्या करें? कम करें, ज़्यादा करें, क्या करें? Remote है. Okay. So this is another name is bell curve. The third name which is often used is known as Gaussian. Gaussian is the third name which is used for the same distribution. So whenever people say normal, bell curve, Gaussian, they basically mean the same distribution. Make sense? Okay. Now, let's look at how the distribution looks like. The normal distribution looks just like a bell. This is how the distribution looks like. I mean, not exactly, my drawing is not good, but I mean, you get the point, right? It looks like this, it looks like a bell. So now let's understand why is this distribution A so popular, and B, what are some of its properties, right? The reason this distribution is popular is if you look at this distribution, you will get a lot of logic behind it, right? So what this distribution saying? This distribution is saying if this is that variable, some variable X, and this is what is in Y-axis of a distribution? Probability. So from this distribution, what is the most typical feature? Or what is the most typical features of the distribution? The most typical features are A, very low values are very low in numbers. Very high values are very low in numbers. Most of the values lie around the average. Right? If you think of any variable, they will follow this kind of distribution. Think of height, right? Height, most of the people given a particular country will have an average height. Very few people will be really tall, very few people will be really short. Think about weight. Typically people will be around the average. Very few people will be very highly weight. Very few people will be very small, low weight. Make sense? Yeah. So most of the distributions of, or most of the variables that you will see in practice will follow this bell shape. Okay. That's one of the reasons of this being so popular. Second reason is mathematically it can be shown irrespective of whatever distribution you have. If you have a large number of observations, every distribution converges towards normal. It can be mathematically shown that irrespective of whatever is the underlying distribution, if you have large enough observation, large enough typically means greater than 30. If you have greater than 30 observations, your distribution is, or your distribution can be approximated to be normal. It will not exactly be normal, but it can be approximated as normal. So for all practical purposes, the only distribution that you should know is normal distribution, barring some exceptions, right? So what are the exceptions? The exception, one of the most important exception of normal distribution is the return from a stock. So people who invest in stock, the return from a stock is not normal. It actually follows a distribution known as log normal, right? Similarly, if you look at distribution of earthquakes, which are rare events, right? If I plot the frequency of earthquakes in a particular year, it will not be normal, right? Barring those cases, one of the cases, whenever you talk about stock returns, it will not be normal. Whenever you talk about any rare event, it will not be normal. Barring those two cases, everything can be approximated to normal. Or even if it is not normal, we will assume it is normal. Okay. Any question? Now, what are the features of normal distribution? One of the features of the normal distribution is it is a continuous distribution. So what do you mean by continuous distribution? It gives you probability for all possible values between -infinity and +infinity. Now that value might be very low, but it will still give you a value. So this distribution continues towards -infinity here and continues towards +infinity here. Yeah, that is one. Second, in normal distribution, the mean is exactly equal to median, which is exactly equal to mode. In a normal distribution, mean, mode, and median are all equal. You should note down these because we will be using these features very exhaustively. Just note down these 2-3 features. Okay. Normal distribution is a continuous distribution. Second, a normal distribution, in a normal distribution, mean is equal to median is equal to mode. Right? Okay. Third property. A normal distribution is symmetric about its mean, median, and mode. Symmetric means if this is the mean, which is again the median and the mode, then the right hand side of this line will look exactly same as the left hand side of this line, right? That's what happens to a bill, right? If you split a bill by middle, you get two exact symmetrical parts, right? So the normal distribution is symmetric about its mean. This is the third property. Now, since it is symmetric about its mean, if I go a delta distribution to the right, or forget about delta, D distribution to the right, and I go D distribution to the left, the probability will be exactly same. Yeah. Okay. If I calculate the area to the right of this and I calculate area to the left of this, they will be equal. Okay. Jot down these properties. These properties will be using, right? Later on, what I've seen is people say, how is this happening? Right? So jot down these properties. Okay. Now, next property. If I know, say this is a normal distribution, right? If I know the probability to the right of this line, how do I find the exact symmetrical point? I travel the equal distance on the other side. Make sense? Sorry? What is 1 minus? No, what I'm saying is, let's say this area to the right is A, right? How do I find another point that has same area to the left? I travel the exact same distance from the mean. Yeah. So these are the properties of normal distribution. Now, a normal distribution which has a mean 0 and a standard deviation of 1 is known as standard normal distribution. A normal distribution with a mean 0 and a standard deviation of 1 is known as standard normal distribution. Okay. Normal distribution with mean 0 and standard deviation 1 is known as standard normal distribution. Okay. Now, next property. A normal distribution is written as n within bracket its mean and within bracket separated by a comma its standard deviation. This is how you will refer to any normal distribution. N within bracket irrespective mean comma standard deviation. So our standard normal distribution should be referred to as n 0, 1. This means a standard normal distribution. Yeah, we'll come to that. It is absolutely possible. Okay. Clear? By clear, I mean this is the property to clear to. Okay. Okay. Now, so all of you understand standard normal, right? Now let's look at 3 most important properties of normal distribution. Let's say this is the normal distribution and this is its mean. Okay. If I travel 1 standard deviation to the right and I travel 1 standard deviation to the left, the area bounded by these two will be 66% of the total area. Or the probability that a random variable will lie between mean plus 1 standard deviation and mean minus 1 standard deviation is 66 point something percent. Remember 66. Between mean plus minus 1 standard deviation. That is why when we looked at dispersion, I clearly told you, you will find bulk of the observation between mean plus minus 1 standard deviation. Because you find bulk of the observation, 66, right? And as we know, most of the variables are normal. Yeah. So whatever is the standard deviation, if you travel 1 standard deviation to the right and 1 standard deviation to the left, the area between those will be 66% of the total area. How can I say? If you look at the expression of normal distribution integrated between minus 1 standard deviation to plus 1 standard deviation, it comes around 0.66. 0.667 something. No, it will be same. It will be same irrespective. If it is a normal distribution, it will be 66%. Absolutely, everything that I'm saying can be proved. Abhi, don't go into the proof. तो उसके लिए you will need integration and all of that, right? Let's not go there. Okay, so area between plus minus 1 standard deviation is 0.66. I mean, it's not exactly 66. It is 66 point something. I don't remember the rest. So for now, you assume it as 66%. It is a good enough approximation. Now, the area between mean plus 2 standard deviation and mean minus 2 standard deviation is 97%. So 66 is between plus minus 1 standard deviation, 97 is between plus minus 2 standard deviation. Okay. Now, the third property is the area between mean minus 3 standard deviation and mean plus 3 standard deviation is 99.7%. So remember 3 numbers, 66, 97, 99.7. Right?
So could you please repeat 97?
So area between mean plus minus 3 standard deviation is 99.7%.
I'm asking for 97.
99.7%. So
Sir,
if I tell you,
97
sorry,
sir, asking to repeat for 97.
97 is between plus minus 2 standard deviation.
2, okay.
Okay, so if I tell you that a variable is a variable follows standard normal, right? Tell me how much probability, or tell me what is the probability that a value will lie between plus minus 3. What will that be? 99.7. Because it's a standard normal. Standard normal means mean 0, standard deviation 1. So plus minus 3 standard deviation comes out to be plus minus 3. Make sense? Okay, now the next property. The next property of normal distribution is if x is a variable, follows normal distribution with mean m and a standard deviation s. So when I say follows in mathematics, it is represented by tilde. So this statement basically means if I get a probability distribution of x, it will be a bell shape. Bell shape such that the mean of the shape will be at m and the standard deviation will be s. Yeah, that's what this means.
Sir,
Follows.
in normal,
Sorry?
sir, in normal distribution, the graph will never be left curved or right curved. I mean, left.
Graph will always look like this, symmetric.
Okay.
So,
So
could you please repeat if condition?
Yeah, I'm saying that, I mean, forget if, right? X follows normal m comma s basically means x is a variable, let's assume age. If I plot that age, get a frequency distribution of that age, it will look exactly like a bell with a mean at m and a standard deviation of s. Right? That's what this means. Now I'm saying if a variable follows normal distribution with a mean m and a standard deviation of s, then x minus m divided by s will follow a standard normal. If x follows a normal distribution with a mean of m and a standard deviation of s, then x minus m divided by s follows normal 0, 1.
Here
What
x data point on x-axis, right?
Yeah. So what I'm saying is, let's say I have a variable x that follows, let's say x, let's say not say is x, let's say age, right? Age follows normal distribution, right? And these are its values. Then if I calculate the average here, and if I calculate standard deviation, this is the average, this is the standard deviation. Okay. Then what I'm saying is, if I subtract from each value the mean and divide each value by the standard deviation, then the newly generated series, let's say this is age transformed, will follow a n01. See what will happen if you subtract the mean from the value, the mean shifts to 0. Take a sum of this. Okay. So if you sorry, what was I saying? Yeah, so if you subtract the value from the C, if you have any series, subtract mean from every value, what happens? The mean shifts to 0. Similarly, if you have any series of data, divide it by the standard deviation shifts to 1. Okay, so when I do both, what happens? Mean shift to 0, standard deviation shifts to 1. Now, why is this important? Why do we need this relationship? The only reason we need this relationship is prior to the advent of computers, people did not have a way to figure out probabilities even if they knew normal distribution. People knew normal distribution, but there is no way that you can tell what is the probability between -1 and +1. You would have to physically integrate the whole equation to get the value. So what some of the statisticians did was they came up with a table known as Z table. Now, what is the Z table? The Z table or the Z score table is a table which gives you cumulative probabilities for standard normal. Now, where is it used? We'll do an example. Let me first tell you what this table means. So you see this number 0.0003. See this number 0.0003? What this basically means is the probability to the left of -3.4 is 0.0003. Probability to the left of -3.4 in a standard normal distribution is 0.0003. Now tell me any other number. Tell me any number. 21. Oh, don't go that high. We'll come to 21. Yeah. Let's say 2.2, right? So what I do is I look for, so these are all negative, right? So I'll go to positive. Do you see 2.2 here? Yeah. This is 2.2, right? Let's say I want probability for 2.23. What I do is 2.23, right? So this is 2.2, 2.21, 2.22. So these are the second place decimals. Okay. 2.2, 2.21, 2.22, 2.23. So the area to the left of 2.23 is 0.9871 or 98.71%. Right? Now, what did we say that area to the now if you talked about 21, right? So if you want to calculate 21, you see beyond 3.4 there is no value, right? Which basically means any value to the right hand side of 3.4 will have a probability of almost 1 to the left hand side. 3.4 is the value. Okay. Let's say this is normal distribution. It is standard normal, right? So the mean is at 0. So this is 0. 3.4 will be a line to the right of 0. Yeah. Distribution में x-axis values of the variable है. Again, probability distribution. X-axis, what is the x-axis? X-axis value of the variable. अगर आप एज का डिस्ट्रीब्यूशन की बात कर रहे हो, एक्स एक्सिस में एज होंगे, वाई एक्सिस में प्रोबेबिलिटी ऑफ दैट एज होगा. नहीं, 3.4 तक नहीं रहेगा. विल कम टू दैट, राइट? अभी इमेजिन करो आपके पास एक वेरिएबल है जो नॉर्मल स्टैंडर्ड नॉर्मल फॉलो करता है. ठीक है, स्टैंडर्ड नॉर्मल फॉलो करता है, तो उसके प्रोबेबिलिटीज यहां से मिल जाएंगे, है ना? उसका प्रोबेबिलिटी यहां से मिलेगा ना?
So
नहीं मिलेगा कि नहीं मिलेगा? I can literally see, right? I can. You don't agree? Okay. Tell me any. That's what I said, right? Tell me any number. 3.4 तक इसीलिए है क्योंकि 3.4 के बियॉन्ड जो वैल्यूज होंगे, सी 3.4 के नंबर, लास्ट नंबर क्या है? लास्ट नंबर को देखो आप, इट इज ऑलमोस्ट इक्वल टू 1. तो अगर 3 पॉइंट समथिंग में ही आपको 1 का मिल गया है, उसके राइट साइड में लेफ्ट का प्रोबेबिलिटी क्या होगा? 1 ही होगा ना। एज की बात नहीं कर रहे हैं ना। अब मैं नहीं, एज पे हम आएंगे, आपका क्वेश्चन में आंसर करूंगा, पर अभी अंडरस्टैंड, इमेजिन अ वेरिएबल जिसका मीन 0 है। एज का मीन 0 तो नहीं है ना। हाँ, एक वेरिएबल है जिसका मीन 0 है और जिसका स्टैंडर्ड डिविएशन 1 है। ऐसा एक हाइपोथेटिकल वेरिएबल आप ले लो। अगर वो वेरिएबल एग्जिस्ट करता है, उस वेरिएबल के लिए यहां से प्रोबेबिलिटी आ जाएगा ना। ये एग्री करते हो ना आप? हाँ, अभी एज पे आते हैं। सपोज आप एज के लिए निकालना चाहते हो, ठीक है। नाउ आपको, दिस इज व्हाट यू विल डू एज एक्सरसाइज। नाउ व्हाट आई डू, आई एम सेइंग इज, I need probability that age will be greater than say 30, right? And what I am saying is the mean age is 32 and the standard deviation is 2, not 2, sorry, 20, right? I'm saying the mean is 32, standard deviation is 20. I am also saying age follows normal distribution. Now tell me, what is this probability?
Sir, can you please explain that Z values, those that chart?
Okay. So this chart, the way you read this chart is, suppose you want to know how much area is to the left of 0.71. What you do is go to 0.7. This is 0.71. See, this shows the second decimal places. So area to the left hand side of 0.71 will be 0.7611. Okay.
Got it.
So what does this
आप परसेंट
0.00,
में बोल सकते हो, 0.76 भी बोल सकते हो, both are same ना। 0.76 is same as 76%.
So what is 0.7 here?
What is 0.7? 0.7 is the value of the x value of the variable, and these are the probabilities. Let's take an example, right? Okay.
What is the significance of area on the left? Can you explain that again?
No, don't look at significance right now. I'm coming to it, right?
Why
So,
we are calculating?
So for example, let's say I want to solve this question, right? You are doing an analysis where people had asked you, what is the probability that a person that I randomly pick will have an age of 30 and more? This is the probability then that you're calculating. Yeah. Okay. Now, how do you go about this? Now I have told you that age follows normal distribution, right? So I've said you that age follows a normal distribution with a mean of 32 and a standard deviation of 20. Make sense? Okay. Then age minus 32 divided by 20 follows what distribution? This distribution, right? Okay. Now I want to calculate the point of reference. Here is 30. Right, point of reference is 30. I need to calculate age greater than 30, no? So what is age greater than 30? 1 minus probability of age less than equal to 30. You know, all of you are fine with this, right?
Yes, sir.
Huh?
Yeah.
Yes,
No?
sir.
Sorry, all of you understand this?
Yes, yes.
Yes. Yes.
Yes, sir.
Okay. So now I need to calculate age less than equal to 30, right? Probability of that. Now 30 in this distribution corresponds to what point in N01? 30 in this distribution corresponds to this point in the N01 distribution. So how much is this point? This is 2 by 20, right? 2 by 20 is 0.1, right? So I need to calculate how much area is to the left of point 1. You understand? I need to calculate probability less. So I need to calculate at the end of the day probability that age is greater than 30, which is equal to 1 minus probability age less than equal to 30. Now, this 30 point is corresponds to which distribution? N32, 20. Now what I'm doing is I'm taking this distribution and translating it to N01. क्योंकि टेबल हमारे पास N01 के लिए है, हर नॉर्मल डिस्ट्रीब्यूशन के लिए तो है नहीं, तो हमको क्या करना पड़ेगा, जो अपना डिस्ट्रीब्यूशन है उसको N01 बनाना पड़ेगा. कैसे बनाते हैं? मीन सब्ट्रैक्ट करके और स्टैंडर्ड डेविएशन से डिवाइड करके. तो मैंने सेम चीज किया है. 30 minus 32 divided by 20 gives me minus 0.1 actually. Minus 0.1. कौन सा?
Sir, can you draw the graph? I mean, that will be much more clear.
Graph.
In distribution graph, that will be much more clear then.
हाँ, तो हम क्या कर रहे हैं? सपोज ये है आपका एज, जिसका मीन एज का डिस्ट्रीब्यूशन, जिसका मीन है कितना? 32 एंड इसका स्टैंडर्ड डेविएशन 20 है. ठीक है, राइट. मेरे को फाइंड करना है एक पॉइंट के लिए जो है 30. राइट. अभी लुक एट दीज टू लाइंस. ये जो लाइन है ये बता रहा है अगर एक वेरिएबल नॉर्मल डिस्ट्रीब्यूशन फॉलो करता है विद अ सर्टेन मीन एंड अ सर्टेन स्टैंडर्ड डेविएशन, अगर हम मीन उससे वैल्यू से सब्ट्रैक्ट करते हैं और स्टैंडर्ड डेविएशन डिवाइड करते हैं, राइट, दैट वेरिएबल बिकम्स देन द पार्ट ऑफ अ नॉर्मल 0-1 डिस्ट्रीब्यूशन. हाँ, कोई भी नॉर्मल डिस्ट्रीब्यूशन से अगर आप उसके मीन से सब्ट्रैक्ट करोगे और स्टैंडर्ड डेविएशन को डिवाइड करोगे, वो N01 बन जाता है, स्टैंडर्ड नॉर्मल बन जाता है ना? हाँ, लेफ्ट का ही, राइट का, राइट देखना है तो 1 माइनस कर लो ना. हाँ, सो ये समझ में आया? तो व्हाई वी आर सब्ट्रैक्टिंग 32 एंड डिवाइडिंग दिस बाय 20? We want to convert this to a standard normal, क्योंकि टेबल हमारे पास स्टैंडर्ड नॉर्मल का ही है, और स्टैंडर्ड नॉर्मल में टेबल में हमेशा ये लेफ्ट हैंड साइड का एरिया देता है. हमको चाहिए राइट हैंड साइड का एरिया, तो हम 1 माइनस करेंगे, है ना? तो ये बन गया -0.1. ठीक है, अभी हमको देखना है कि स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन में हाउ मच एरिया इज टू द लेफ्ट ऑफ -0.1. ओके, so I go to the standard normal, I go to -0.1.
What is area that you are saying here? Is it the probability? What is it?
This area is probability, na? In probability distribution, the area is always probability, na?
Okay. The left side.
Sir, this is a standard table that is going to use for all the calculations.
Normal distribution calculation के लिए ये table use होगा.
ये standard table है, मतलब सबके लिए use होगा, right?
हाँ. तो -0.1 के लेफ्ट साइड में कितना एरिया है? 0.46, राइट? सो वी हैव गॉट this probability as 0.46. So our answer will be 1 minus 0.46. Make sense?
Sir, why we did minus from 1 minus 0.46?
One second, one question at a time. You were saying mean was 20. I thought it was 20. What could you do? So you would do this 20 here. No. You will always look at the left hand side. No, I mean, so for example, let's take another example, right? Let's say I want to know what is the probability that age is greater than 10 under the same scenario. So age is greater than 10, but the Z table always gives you area to the left. Right? So if you want to calculate area to the left, or if you want to calculate area to the right, what will that be? 1 minus area to the left? So I will do just this. Right now here, instead of 30, I will use 10 here, and whatever the outcome. Yeah. Okay.
So, sir, we can say 66% is a probability to occurrence of age 30. I mean,
there is 60. There is actually 54% probability that you will get a person of age greater than 30. Okay, so for people who are getting confused, that's why I told you that we'll be using these properties very exclusively. Now understand, ये geometry का खेल है, ठीक है? Area total 1.
So from where we have 0.46?
सर Z टेबल में उस पे आता हूँ, एक सेकेंड आप मेरी बात सुनो.
Fine, sir.
Okay. एरिया, टोटल एरिया, ये जो कर्व है ना, टोटल प्रोबेबिलिटी तो 1 ही हो सकता है ना? ऑल ऑफ यू एग्री विद दैट. प्रोबेबिलिटी 1 से ज्यादा हो ही नहीं सकती. तो ये जो कर्व है, जो एरिया है, वो विल ऑलवेज बी 1. ठीक है. अभी अगर कोई आपसे पूछे कि चलो मेरे को बताओ व्हाट इज द प्रोबेबिलिटी दैट दिस वेरिएबल विल टेक अ वैल्यू ग्रेटर देन 30, तो आप करोगे क्या? पहले 30 यहाँ पे कहाँ है वो पॉइंट आउट करोगे, है ना? सपोज 30 यहाँ पे है, करेक्ट. उसको चाहिए क्या कि वेरिएबल का वैल्यू 30 से ज्यादा हो. इसका प्रोबेबिलिटी क्या है ना? तो वो प्रोबेबिलिटी क्या होगा? ये जो लाइन है, इसके राइट साइड में जितना प्रोबेबिलिटी है, दैट विल बी दैट प्रोबेबिलिटी. ऑल ऑफ यू एग्री विद दैट, राइट? सो आई नीड टू फाइंड दिस एरिया, है ना? पर मेरे को मिलेगा सिर्फ लेफ्ट हैंड साइड का एरिया, तो मैं क्या करूंगा? 1 माइनस लेफ्ट हैंड साइड करूंगा तो राइट आ जाएगा ना. टोटल 1 है, राइट मेरे को फाइंड करना है, लेफ्ट मेरे को दिया जा रहा है, तो 1 माइनस लेफ्ट विल गिव मी राइट. दिस इज व्हाट यू विल बी यूजिंग एवरीवेयर. नाउ कमिंग टू दिस पर्टिकुलर केस, यहाँ पे हमको फाइंड क्या करना था कि एज इज ग्रेटर देन 30. तो एज ग्रेटर देन 30, जेड टेबल मेरे को देता है हमेशा लेफ्ट हैंड साइड का. ग्रेटर देन 30 मतलब राइट हैंड साइड का एरिया फाइंड करना है ना. जेड टेबल हमें को देता है लेफ्ट हैंड साइड का, तो 1 माइनस लेफ्ट हैंड साइड करेंगे तो राइट आएगा. अभी राइट आएगा, मेरे को ये समझ में आ गया, पर ये जो एज है ये स्टैंडर्ड नॉर्मल तो है नहीं, तो इसको स्टैंडर्ड नॉर्मल बनाना पड़ेगा, है ना? तो स्टैंडर्ड नॉर्मल कैसे बनाएं? हम ये लास्ट प्रॉपर्टी जो हमने स्टडी किया है उसको यूज करेंगे. उसमें क्या बोला गया है, आपके पास अगर कोई भी वेरिएबल है, एक पर्टिकुलर मीन और एक पर्टिकुलर स्टैंडर्ड डेविएशन से नॉर्मल फॉलो करता है. नॉर्मल फॉलो करता है मतलब बेल शेप टाइप का दिखता है, तो उससे अगर मीन सब्ट्रैक्ट करके स्टैंडर्ड डेविएशन से डिवाइड करोगे, वो बन जाएगा स्टैंडर्ड डेविएशन, सॉरी स्टैंडर्ड नॉर्मल, है ना? We did exactly that, and then we got a value of minus 0.1. So now we are looking for an area to the left of minus 0.1 in the Z table. Clear? Okay. Now, if you go to the Z table, look at minus 0.1. This is minus 0.1. The area to the left is 0.46. So I just put in 0.46 in this place, and you will get a result of 54%. Make sense? Okay, now
right,
let's do another case. A particular point में तो कोई probability find नहीं कर सकता. Using Z table क्या मैं बता, उस पर भी आता हूँ. There is a fallacy, उस पर आते हैं. Okay. Now अभी what we will do is we will find out probability that age lies between 20 and 40, है ना? This is the probability that you will find. Now distribution remains exactly the same. Let me know when you need the Z table. Z table चाहिए होगा कि नहीं चाहिए होगा? you need to find probability that age will lie between 20 and 40, where age follows a normal distribution with a mean of 32 and a standard deviation of 20. People who are online, you understand what has to be done?
Yes, sir.
Okay. Now let's work it out, right? So I need two boundaries, 20 and 40. I'll convert both of them to standard normal, right? So what happens? So this becomes 20 will become 20 minus 32 divided by 20 greater than equal to age less than equal to 40 minus 32 divided by 20. No? So I am now looking for basically what is this coming out to be? So 8. Huh? Sorry? Minus 0.6 greater than equal to age less than equal to 0.4. This is what is coming, right? Yeah. Okay. Now, this probability I can write it in multiple ways, right? What I can write is this probability is probability of age less than equal to 0.4 minus probability of age less than equal to minus 0.6. ये कर सकते हैं? देखो, लेकिन जियोमेट्री का समझ है, अंडरस्टैंडिंग, और इसमें कुछ नहीं है. जब आप छोटे थे केक का एग्जाम्पल नहीं पढ़ा था, एक केक को दोनों हिस्सों में बांटोगे तो कितना रह जाएगा, उसी टाइप का है. तो ये टोटल केक है. आपको क्या बोला गया है, ये यहाँ से यहाँ तक का काटो आप केक को. तो यहाँ से कैसे काट सकते हो? पहले आप यहाँ पे काटोगे, इसका लेफ्ट हैंड साइड का एरिया फाइंड करोगे, है ना? फिर यहाँ पे काटोगे, इसका लेफ्ट हैंड साइड का एरिया फाइंड करोगे. Subtract the second one from the first one, you will get area in the middle. Make sense? Okay. So now in the Z table, you will tell me what are the values we are looking for. Minus 0.6. So this is my 0.2743. 0.2743 noted. Okay. Next is 0.4. 0.4 is 0.6554. Noted? हाँ, अभी बताओ कितना प्रोबेबिलिटी है? हाँ, 38%. चलो 38%. Clear? Okay. Any questions on this? अगर आपने ये समझ लिया ये कैसे कैलकुलेट होता है, आपका एस्टिमेशन हाइपोथेसिस टेस्टिंग क्लियर है.
Sir, in the Z-score table, why we are using only 0.00?
Sorry, why? Because I am looking for exactly 0.4 na. If I was looking for 0.41, I would have used this. So 0.4 is then second decimal place.
Okay.
Sir, so whatever value we have got from Z table for 0.4 and minus 6, we'll subtract those from minus 1. Sorry, from 1, right?
No, why will you subtract them from 1? See, Z table gives you area to the left, right?
Yes.
Now understand what am I trying to find. I am trying to find the area between 0.4 and area between minus 0.6 and 0.4, right?
Mm-hmm.
So what I do is I calculate area to the left of 0.4. I calculate area to the left of minus 0.6. If I subtract the second one from the first one, I get area in the middle, right?
Okay, so we'll get 0.38 something and we'll multiply it by 100 to get it into the percentage. So
Correct.
that comes 38%. Okay.
Correct. Clear? अगर ये आपका क्लियर नहीं हुआ है तो आपके लिए तो बहुत स्ट्रगल है फिर बाद में, ठीक है?
Sir, how it came 38%? We have not taken any value of age.
Oh no, I did. Sorry, I did not note it down. Sorry, my bad. So see the area to the left of 0.4. So this is 0.4. Area to the left is 0.65. Yeah. You understand, right?
Mm-hmm. Yeah.
So this is 0.6554. Now, then I need area to the left of minus 0.6. So I go to the above table. I look at area to the left of minus 0.6. It is 0.2743.
Okay. Then
So
we
minus
subtracted.
0.2743. If you subtract it, they will get it somewhere around 0.38, which is 38%.
Okay.
Okay. Is this clear? Okay. Now,
Yes, sir.
sorry? Okay. One last thing before we close the class today, which will talk about a theorem known as central limit theorem, right? We'll talk about central limit theorem or CLT. Now, what is central limit theorem? Let's take an example and understand, right? I was thinking whether we should do this today or tomorrow. Yeah, let's do this tomorrow because today we'll not be able to finish this. Okay, so for today, let's do couple of exercises, right? Let's say I want to find probability to the left of minus 0.6, right? I want to find probability to the left of minus 0.6. Not CLT. CLT I will not do today. Okay. I'm just giving you another example just to reinstate whatever we have done. So I want to find probability that a certain variable takes a value less than equal to minus 0.6. Yeah. Area less than equal to minus 0.6. Hai na? Okay. Now, the only constraint is you will not get to look at the negative table. You will only have to find it using the positive table. How will you do it? Huh?
1 minus 0.7257.
Answer. 1 minus
0.7257.
1 minus 0.7257. है ना? All of you understood कहाँ से आया? हाँ? अब देखो ये सिमेट्रिक डिस्ट्रीब्यूशन है अबाउट 0. तो माई 0.6 के राइट में जितना एरिया होगा उतना ही एरिया माइनस 0.6 के लेफ्ट में होगा. तो 0.6 के लेफ्ट का एरिया निकाल लो, 1 से उसको सब्ट्रैक्ट कर दो, राइट के एरिया में निकल गया. यूज दैट वैल्यू, है ना? तो Z टेबल जो है वो हम जब कॉलेज में थे हमको ये एक बुक में आता है ना, एक पेज मिलता था, एक पेज हमको मिलेगा, एक पेज नेक्स्ट बेंच को मिलेगा. तो ऐसे कैलकुलेट करते है ना
सर. बट इसके लिए x को स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन होना पड़ेगा.
नहीं
right?
है तो बना लेगा, आप बना लेना कि उसमें क्या है.
X is less than equal to 0.6, so whether it is standard normal distribution.
देखो मैंने पहले क्या बोला, 99.9% केस में आपका वेरिएबल फॉलो करेगा नॉर्मल, ठीक है. अगर नॉर्मल फॉलो करता है उसको स्टैंडर्ड नॉर्मल बनाना इज वेरी इजी, राइट? You will just subtract the mean and divide by standard deviation.
But here we don't have mean and standard deviation. The example which you have.
मैंने बोल दिया ये स्टैंडर्ड डिविएशन स्टैंडर्ड नॉर्मल फॉलो करता है. अगर इसने नहीं बोला है तो ऑब्वियसली मीन एंड स्टैंडर्ड डिविएशन यू कैन कैलकुलेट फ्रॉम द डेटा ना.
Here the data is given.
Sorry?
The example which you gave just now, here you just asked probability of x is less than equal to
Yes,
minus.
I also told that this follows standard normal.
Okay.
Yeah.
So can you please repeat how to read the z-score table?
Z-score table, this is the value and this is the second decimal point. If I want to find area to the left of 1.72, this is 1.7, this is 1.71, this is 1.72.
Only we can read the till the second place decimal.
Yeah, only till second place decimal. Yeah.
Okay.
Any other questions? Probability will never be 3.1. No?
Sir, the last question you asked where you have said we don't get to look at the minus value but at the positive. Sir, why did we subtracted it from 1?
Okay. Let's say this is the normal distribution with a mean at 0. If I need to calculate area to the left of say -1, what I can do is I can calculate area to the right of 1 and use that as this area because this is a symmetric distribution. So even using the positive table, you can calculate area to the right of every positive number and use that as a left area of any negative number.
Okay. So we just use the 0.6 value, that is 0.7257. So this is to the right of the
This is to the left of 0.6.
This is to the left of 0.6.
Yes.
Okay.
So how much area will be to the right of 0.6?
1 minus. Okay.
Exactly. So that much area will be to the left of -0.6. Sorry, there was which one? These values, these are known as Z values. Another name of normal distribution is Z. Yeah, you'll have to figure it out. You have done it? Okay. See, I have not done it. He was also saying he has done it with subset. So if it is working, it's fine. Okay. Now one thing, right? So before you come to the class tomorrow, I would really encourage you to look at the shape of the normal distribution and think about how you can calculate different probabilities, right? Understand that shape, because tomorrow whatever we are going to do, we are going to use that shape and build on it. No, we will only stick to normal. Okay, any questions on this? Cool. I will see you guys tomorrow.